Hello, good morning everybody. Welcome back to lecture 8. Today we're going to talk about data integration for business intelligence. Following up from last week when we spoken about how to structure our data, this week complements last week where we tried to build a sort of unified access for different sources of data coming from different devices, different cloud sources, different web sources to enable decision makers to interpret things and do all these business intelligence decision making processes in strategic middle level and lower level decision making. Okay, so I'm gonna take you to 3 elements for today. The first one, where we're gonna talk about why we really need this sort of data integration and what is data integration, the different types of data integration. I will talk to you about abstraction levels and how these levels of integration trying to build a sort of heterogeneity between different levels of data model. So from the warehousing and data mining, which we will discuss in more details next week, until the user interface, which is integrating data by the user, by the end user. And then I'm going to talk to you about applications and examples of data integration. So in our lecture today, we aim to achieve 4 key objectives. First, we will try to understand the role of data integration in business intelligence systems and how it enhances decision making for different stakeholders who have different sources of data, definitely. We will try to understand the stages of data integration as a process. We will try to see this heterogeneity and these levels of abstraction from the warehousing and hardware integration until the final interface integration and semantic integration. I will talk to you about different applications and examples of data integration, portals, different things. So let's go ahead for today's lecture. The first section, why and what data integration. So the first reason is mainly to set an existing information system or business intelligence system, make it an integrative view interface for different stakeholders who will do the business intelligence decisions. So this would develop an integrated view that can be created to facilitate information access and reuse, retrieval of data through a single information access point. So whatever these decision makers, if they use different devices, laptops, tablets, mobile phones, wherever they are located, whatever the language they have, we need to develop this sort of data integration for all of them. So the interpretation can be commonly understood and agreed from different parties. Another reason why we need data integration for business intelligence is again to complement different sources of data and combine them in a comprehensive way to satisfy certain data needs. So for example, if we wanted to see profitability, we can have access to aggregated data from different sources around the world. If we have a multinational corporation, we need to find concepts and terminologies that once we search for, we can have all the relevant data supporting the concept of profitability. So we can have a branch and subsidiaries profitability and the overall corporate profitability. So this is mainly enabling these reporting techniques and fulfill certain information needs within this comprehensive data set. Another reason, which is for sort of industrial reason or output reason, is that once we have data integration, we can use this for queries and reporting especially when it comes to prescriptive analytics, statistical analysis, when it comes to online analytical processing or the OLAP, especially if you have cloud sources of data. So we have online analytical request with a real-time processing of data, or data mining, which we will cover next week. All of this will enable business intelligence functions such as forecasting, decision making, enterprise-wide planning, and enterprise systems management. So what is data integration? It is frankly a combination of technical and business procedures and processes that we use to combine data from separate separate and geographically allocated devices into meaningful and valuable information interface. It combines selected systems to form a unified new whole, and gives users a sort of the illusion of realistic interaction, so they will see they have a single system despite having different systems with different reporting techniques, with different organizational routines. So they need to see one whole. That's the point, instead of separate systems. And I think if we apply this to education, all of us would love to have one interface to see everything. One Northumbria, for example, is a sort of platform where I can have access to eVision, which is student records, and my own academic records when it comes to supervision and everything. I can see my teaching material, I can see my HR system, I can see my payroll. Everything is integrated in one platform. So it encompasses sort of discovery, cleaning, monitoring, transforming, delivery of data from a variety of sources. It is by far the largest portion of building a data warehouse. So this is a bit critical, guys. Once you set the structure, this is how you do, I would say, the realistic job, the heavy job when it comes to integrating data, and put everything into a sort of interface for the final user. So I would start with data integration and how it works. So you have a source, another source, and you want to build a target which is integrating different types of data. You might build, like, for example, 5 criteria where all data from source 1 and source 2 could get together, or you can have partial data from source 1 and partial data from source 2 to complement each other's. So these sources could be different branches, and the target could be, for example, profitability, return on investment, something. Or you can say, okay, the first source is a department, which is, for example, purchasing. The second source is operation and accounting, and then the target is to have, for example, income statement. So it's a way to embed your data from different sources and integrate it into target database or application of your choice. A different level of data integration could be sort of data migration, where you have the first source and you want to migrate this into a completely different one. So offline, all the legacy system that you wanted to move completely into the cloud. And it is the process of migrating data from one data source to another without migrating any errors. So we are not just taking a backup, no, we are taking the right version and avoiding any repetition, replication, inconsistency in data. It aims to extract the data correctly, transform it into a new form that could be easily understood and analyzed. So extract data from a homogeneous and heterogeneous data source, transform the data for storing it in the proper format or structure for query or analysis, let's say in the cloud, load it into the final target. And you can keep doing this. A very good example, as I told you, linking between the offline and online version, the cloud system, for example. So this is how it works. Sort of, you have data warehouse where you have, for example, ERP system for purchasing and logistics. You have customer relationship management system. All of them would feed back into the cloud server in up-to-date manner and in a good way. So we can really read at the end of the day, are we achieving profit? Are we achieving progress? Data synchronization, which is another level of data integration. And in this case, you have a source, you have another source, and you try to synchronize them, which means there are different sources of data, for example, mobile phones, that are not integrated with the offline version in PCs. And you frankly allow your sources or devices to have specific moments where they go online and synchronize their offline data with the online data. It is the process of data matching in this case between two or more data sources, either in real time or batch synchronization. So you can do this promptly. Let's say you have a loan tracking system and you want to track different installments, payments for a group of people who had a group loan. They are located in different places in one city or maybe in many cities. One of them will pay back on that time, one of them will pay back later. How their data would be synchronized into the loans record. This would happen in real time. This is one option. Second option, every 2 weeks, the microfinance institution or the bank would allow sort of batch synchronization and upload the relevant data and integrate them. So this is another level of data integration. Though it is a bit challenging, data integration easy said than done. Users would be provided with homogeneous logical view of data, physically distributed over different heterogeneous data sources. How we can build this, it's not easy. All data has to be represented using the same abstraction principle, same unified global data model or unified semantic. So we will have similar reporting techniques, consistency of data, no duplication, no conflict. Finding skillful people and data engineers who would be able not just to structure the database but also analyze data and try to develop a workflow, draw actionable conclusions for decision makers and by decision makers is not an easy task. Ensuring accuracy, quality and security of data when it comes to peak hours where the server is slow, and we might have similar things when it comes, for example, to Blackboard, to integrate data in a real time, importing things from Panopto into Blackboard every Monday and Tuesday morning it would be slow and heavy. Similar things. Now we are moving to part 2, where we will talk about the hierarchy of data integration and different levels of abstractions. So when it comes to the abstraction levels of data integration, this is a sort of a picture that tells you it starts where you have data warehouse and data storage from sort of hardware level. You have common data storage, and then you need to build unified data access to multi-storages in different places. And then when it comes to the middleware integration, you need to integrate this, which is sort of infrastructure and the platform level, and then you go to application level, and then the interface level, and the top one is a manual integration. So let's talk about each one of them in details, step by step. So I would start from the bottom level, where we need to have common data storage, sort of data mining as well. You have physical data integration that need to be performed by transferring data smoothly to new data storages, where different sources would feed into a parent data storage or data warehouse. Local sources can either be retired or remain operational, which is okay from time to time, but everything need to be fed and synchronized and integrated into the main warehouse. In general, it provides fast data access. If the local data source are retired, applications have to be migrated to the new data storage as well. So it is not just the data level, the structure level, but also the application level. And an example of this, when it comes to, for example, you got a new job, and you go to you got authorized machine with username and password, where whatever cloud or OneDrive or Dropbox, any cloud applications that you have need to be quite linked to the central system, the IT system of your organization. From time to time, even if you changed your machine, everything should be migrated and saved on the central warehouse. In case local data sources remain operational, periodical refreshing and synchronization need to be done. So this is when it comes to linking data storages with relevant cables and different ways of transferring data. The higher level, not the highest, when this is the second level, when it comes to uniformation or of data access. So a logical integration of data need to be accomplished. Global applications are provided with unified global view. So it unifies again the global access, regardless any geographical locations that you have. So this remote access, remote global access is another dimension of abstraction and heterogeneity. Global provisional access could be time consuming somehow, and this is why we use VPN applications, so we can offer you a sort of uniformed or unified data access. The third level is the middleware level, where we need as institution to provide our users with functionality to solve different aspects of integration problem. So just in case if there is no synchronization, if the real-time synchronization doesn't work, to save their integration efforts, we need to develop a sort of integrative middleware. Different middleware tools usually have to be combined to build an integrated system. I go and urge you to just search about examples of middleware. These are sort of operating systems like Microsoft Office, for example. Integration by applications. So you move from the operating system or the middleware level into application level, where we can use integrative applications that absorb and import different sources of data. So for example, SAS is an application level. When it comes to a multinational corporation who use SaaS, we need to have key terminologies, key criteria, key themes on SaaS. So whatever the data that comes from different sources could be categorized and classified. It's practical for a small number of components system, but if it is very comprehensive and complicated, it would be very challenging to build a sort of integration application. Applications become increasingly fat as the number of system interfaces and data formats increases, and this is normal, and this is why we have different levels of ERP systems and complexities of ERP systems. The level 5, which is common user interface, in this case the user is supplied with a common user interface like a web browser or a mobile interface that provides a uniform look and feel. So you look at your mobile phone and you see the app, how it looks like. This is your user interface. The screen, the monitor of your PC or laptop is your user interface. Data from relevant information systems or business intelligence systems could still be, presented separately, or you can unify them together. So it's up to you. So it's mainly a sort of more a choice of a user. All the integration is done by the user in different of coloring, categorization of data. Let's say, for example, you have your own search engine, your emailing system. So it's up to you to organize the final interface. It is in your hand as a user. Level 6, which is manual integration, and users directly interact with all relevant information in this case. They can manually not just follow a sort of a limited version of themes or categorization by the providers. No, they have full control, and I would say this comes when we have open source software like Python. So you have Python system, and you have completely full control over everything. You can change colors, you can add themes, you can add categories, you can build new coding. So we are done with the second part. Let's review the first and second part. The first one, we've spoken about why we need data integration, and then what is data integration. We've spoken about data integration, data transfer, data synchronization, and then when it comes to data integration, it is not easy. It is a bit challenging. We've spoken about these challenges that we might face whenever we do data integration. And then we've spoken about the second part, which is the hierarchy of abstraction and heterogeneity of data integration, from the warehousing and the hardware level to the infrastructure and operating systems, applications, and final interface levels. Let's talk about examples then, examples or applications of data integration. So frankly, I will talk to you about 9 examples or 9 applications.